Hey guys, this is Carrie, and in this video I'm going to be teaching you how to write a Python script in Sublime Text and run that script from the terminal. So I think a great opportunity for us to write a script for would be, let's say we're in math class and we're learning how to find the slope between 2 points, and our teacher gives us a homework assignment where you have to do this for like, I don't know, 10 questions. Rather than go through the details and, calculate this with the calculator 10 minus 4 with the slope formula, minus 6, minus 3, and do all that work by hand, it actually is the perfect opportunity for us to write a programming script. So I'm going to open up Sublime Text. Now that I've got Sublime Text open, I'm going to start coding in Python. So to code this in Python, I need to save this. I'm going to save it to my desktop folder called Carrie's folder as slope. And to run it as a Python file, it has to have the file extension .py. Now, once you put that file extension .py, the same way that when we coded in HTML and CSS, it color-coded our code, it's going to color-code our code to make things a little more easier to read. So it looks like we're going to be given 2 points and asked to find the slope in all of these questions. So I need to use my slope formula. And I've got it pulled up right here to help remind you. So it looks like we're going to have x1 equals something. Actually, let me go back to the first problem. x1 equals 3, y1 equals 4, x2 equals -6, y2 equals 10. For readability, I'm going to put an extra enter between the two different points to make it easier to see. Obviously, you don't have to do that, but it's nice to make your code readable. Next up, I'm going to put 2 enters here, and I'm going to compute the slope. So now I'm going to look back at the slope formula. So one of the nice things about using the slope formula is that I no longer have to actually worry about these specific numbers that I typed over here. I only actually have to use the variable names on the left-hand side. So it looks like slope is equal to y2 minus y1, all divided by x2 minus x1. And I've used parentheses to properly group these things so that we have this whole thing divided by this whole thing. So I'm going to save this. This should be inside of my desktop folder. Let me move this over here. Inside of my desktop folder, yep, slope.py is in there. And now to run this code, what I'm going to do is I'm going to go to my terminal, and maybe I should use the one from class. I'll use the regular terminal that we've been using in class. Sorry, it's blown up. It just must be from using it in class. So let's see. To run this program now, I type Python 3, just like before. But rather than pressing enter, I press space. And then I drag over the file that I want to run using Python, and I drop it right there. So I have Python 3 space and then the file name, but just from dropping that file. And when I press enter, it will actually run the file. And so nothing happened. So that might throw you off here, but you shouldn't be thrown off. The reason why nothing happened here is I forgot to print out the result. So I need to use that print function. I need to print the slope. So let me save it again. And to rerun it, since I'm going to be running the exact same code, I'm going to use the up and down arrows to go through my list of commands, and it's actually my most recent one. So I want to run the exact same command, and maybe I should just run it through that one more time. You type Python 3, space, drag the file that you've been editing over, and press enter to run it. And it looks like the slope that comes out is -0.6 repeating. So that must be answer choice 3, -2/3. And I'm sure there is a way to write this as a fraction, which would be nice to do. But in our case, we'll just have to think about the decimals ourselves. So let me change this file now so that we can use the same file over and do problem 3. So for problem 3, it looks like the only things that are going to change are not the variable names, not the slope formula, not printing the slope, but just the numbers. So I can quickly go through and do -6 for x1, for y1, 1, for x2, 4, for y1, -4, and now I save it. And once I've saved it with the updated values, I can just rerun that exact same code. So Python 3, drag the same file over, but because I've changed the values, it should give us a different slope. Press enter, and I get -0.5, which is answer choice 3. Much quicker than actually doing this all in calculator. As a further example, let's go through this really quickly. We've got x1 equals 2, y2, 1 equals 5, x2 equals 7, y2 equals 3. I'm going to save it with the updated values, and I'll rerun the same script. And out pops the next slope, so it's -0.4. and that's actually the fraction 2. And so we've got all these questions being very quickly answered using our Python script for slope. So of course this is just one example, but you can think of a number of scripts that might be small, but similarly useful. You could do a quadratic formula one if you're in Algebra 2. If you're doing something for, I don't know, sending out email invitations to a party and you want to insert someone's name in with different names, you could write a script that would plug their names in to each of your emails before sending them off. So these are just a couple of ideas for small scripts that might be useful for you in the future. We're going to do a lot more of these in class, but this is a cool way to write Python code, and it's permanent. So when you close your terminal, you'll still have the saved Sublime text file running.